This is Dr. B here, and let's solve two more gas law problems. They are ideal and combined gas law type problems, but for any of these, just start replacing your data with the letters that correspond to them, and the correct formula should become obvious. Here's one that says, what is the temperature? So I'm going to write T equals whatever, we'll call it X, of 2 moles. Well, that doesn't happen very often because moles goes by the letter N. There are very few formulas that have the letter N in it. I'm already thinking ideal gas law. Who would they say ideal gas? That helps me. It's at 300 millimeters of mercury, and I'm going to assume this is an ideal gas law problem for which it's very picky. They need liters, atmosphere, mole, and Kelvin. I know that 760 millimeters of mercury is a complete atmosphere, so I have something less than half. In other words, I have 307/60ths of an atmosphere. You could do this in a more proper way, but that's how much you got, 0.40 atmospheres. We're at 12 liters of volume. I like those units. That is the correct units. We have everything except our temperature, so we could write down the formula, PV equals nRT. Divide both sides by nR to isolate T. Now we're in a position to simply plug in, throw in those units that you worked so hard to get into the correct types. And there's everything. And it's always fun to, cancel out everything because the correct unit should spit out here. And the temperature at which this occurs is 45 Kelvin. Notice that ideal gas law does not have initial and final conditions. It just has what's in the cylinder kind of a question. Here's another one that should spit out with the combined gas law. Let's see if it does. We got a gas. Its temperature is 14 Celsius. I always use Kelvin. Volume's 4.5 liters. Fine, that's my V. Temperature's raised, so I better have a T1 and a T2. Switch that one to Kelvin. And I double the pressure to 2 atmospheres. Hidden within that, of course, is the initial pressure of 1 atmosphere. So I got all sorts of P's and T's and one of the 2 V's. Can you see how this must be the combined law? It has so much data in it. Solving for the final volume. So we have our SI units. Let's write down the equation. I actually do like to rearrange this, even though it's a pain. Or not really, though. I mean, we need to isolate V2, right? Just throw P2 down there and T2 up there, which is the same thing as saying multiply both sides by T2, divide both sides by P2, and that isolates V2. There you go. Now we just throw in those 5 pieces of data, and if life is good, it will spit out liters. Atmospheres is gone, kelvins is gone, liters is not, and that's what you got, 2.37 liters. These are sample ideal gas law and combined gas law problems.